All right, let's go ahead and get started. First off, do keep in mind your project is due September 27th. Ooh, what's today? 18th. All right, so you got 9 days. Go ahead and keep working on it. Make sure you come talk to me about your design. Otherwise, you'll probably have a lot of issues. Okay, well, I hope everyone enjoyed their vacation. How many of y'all stayed here? 2 people stayed? Wait, the rest of you all left?
Yeah.
Oh, wait, you had to leave because of... That's right. Okay, well, I'm glad everyone made it safely, and we're back, ready to go. So today hopefully we'll finish up with C++ objects, and then next class we can actually start delving more into data structures. We have been talking at least about one data structure, arrays, so far, but then we'll go into linked list. That way we can actually have a comparison of 2 very commonly used data structures. But for today, we're going to hopefully finish up on inheritance, virtual functions, and then we're going to talk about templates or generic programming. And it's very important that we understand templates because we'll be using that throughout the rest of the course. Right, Jonah?
Yeah.
Yeah. Thank you, Joe. All right. Sadly? No. It's good.
Oh, no.
Well, the standard template library uses it, so you have to understand these things. All right. So what was the point of inheritance? Going back to our OOP class.
So we can inherit traits.
Inherit
from
traits.
The parent class.
Right. Yeah. So we can inherit traits from the parent class, and that helped us with
Not having carried this much code.
not ever carry much code. Okay, good. So that was one of the points of inheritance, and then later on you have to use, well, they're called virtual functions, but in Java y'all used interfaces. And what was the main aspect of an interface? Bringing it all back to memory. Remember interfaces in Java?
There's interface in like abstract, right?
Right.
Yeah, okay.
So an interface.
Always use interface over abstract.
Right. So
remember
that, you just made it cleaner. So the interfaces, you could actually use either one, but in my opinion, the interfaces make it a lot cleaner of what you want to do because it decouples your code from But anyways, in Java, you use something called interfaces. C++ doesn't have an interface. Instead, it has this keyword called virtual, which means that it's going to bind what the function being called until later, aka it's making the function abstract. You declare with the word virtual. Okay. Before I continue on, you have to understand there's a difference between compile time binding and runtime binding. In Java, everything was runtime. In C++, I'm going to say for the most part, it's compile time. In other words, compile time means that the compiler is going to figure out which function to call when you compile the code. Runtime means while your program's running, it's going to figure out which function to actually call. This will probably make more sense when we do examples. Let's see. That's nice. Don't know why we're putting that out right now. We're going to try and run through virtual functions because we just need to learn them in C++, and then we're not going to use them again. Or do we use them again? Didn't think so. Good. All right, that's nice. Enough of this class. Okay, let's just get to the actual code. Here we go. Pure virtual function. This is what actually matters. So it does not have a definition. Body has no code, so this is like an abstract in Java. You put the word virtual in the beginning, and then you set it equal to 0. That's right, we're literally setting a function equal to 0 in C++. A class can be the same, can be an abstract class with one or more virtual functions, can contain, et cetera, et cetera. So let's go look at code. Let's get rid of this. Too early in the morning?
Yeah.
Okay. All right, what do we got here? Main.cpp. I have a stream, int main, int arc c, char b. All right, let's, okay, good, so good. Turn 0. Okay. So we could have a class. What do we want the class to be? Class.
Class of Jonas.
Which one?
Jonas. Class of Jonas.
Jonas?
Jonas. Jonas. Like Jonah's name. Jonas.
I heard Jonas. That's how we're going to spell your name, Jonah.
Yeah.
Okay, we'll put an H on it.
It's
Fine.
spelled worse.
All right, so we can have public. Let's go. Well, hold on. We need to figure out a way to inherit it from it. So we'll have a student. There, we're going to do the classic student.
Did he hear it from his parents?
Yeah.
Inherit from. Oh, so, I don't know if we want to delve that deeply into Jonah right now. I'm just going to say, all right. All right, int get age equals 0. So we're not going to define it here. Let's see what else we're going to do. Virtual. I don't know. Well, let's not do virtual. Oh, what else we'd have for our student?
Height.
Height? Okay, okay, fine. We'll go with the standard classic. We are going to not be creative today. And that's fine. All right, let's see if that actually compiles. Oh, yeah, it probably would be an issue. Okay, good. Hey, look, it compiled and ran. That means it's perfect. All right. Now we'll have a class called Jonah. We'll have an inherit publicly from student. All right. Is that going to compile?
Yes.
Yeah, C++ is fine with that. You don't have to actually.
Looks okay to me.
I mean, all you're saying is now Jonah also has some virtual functions. All right, so let's go see if we can actually create a Jonah object. It sounds so terrible.
All right.
Oh, now we have problems. Because the following virtual functions are pure within Jonah.
They're pure within Jonas.
Yeah, they're pure virtual functions. So what does that mean we need to do? Make them unpure. That does not sound right. We need to implement them. How old do you want to be, Jonah?
12.
All right. So is it going to compile now? No.
No.
What
I
for?
only did one of them, right? So you have to get height. He's 5'2".
How high do you want to be? Notice that we did not tell you how many, if it's millimeters, centimeters, inches, feet, yards.
He's only 12 years
Leads.
old. Yeah, so we gotta think about it. Realistic, like 4'3". I'm not 5'2", like 5'2".
All right, now is it going to compile?
Yeah.
Yay! All right, it compiled. Can we create a student?
He's got it. He's a D1 prospect. He's 12 years old.
Can we create a student? Why can we not create a student?
Because those functions they're not pure.
No, because they are pure. we have to dirty them up or whatever. Why is there a bowl?
Somebody must have been eating some cereal. You know? Some of those Cheerios in the morning. Maybe somebody lives in.
All right. All right, let's see. So who wants to point to Jonah? All right. So we have Alex equals a reference to Jonah. All right, there we go. Is that going to work out fine? Can we change Alex to student?
Yes.
Why is that okay?
It's just creating a pointer.
It's creating a pointer. We haven't actually done anything. So Alex is now you're a student. You're not a Jonah. Congratulations.
I'm sorry.
All right, so we can do age. Do Jonah.get age. And that should print off 12. And let's just make sure that happens. Good. Jonah's age 12. We'll go Alex's. Alex is pointing to a student of age. There we go. That was a good way to do it. All right, is that going to be okay? I want yeses. Yep. Because when it finally jumped to the object, it actually existed. So I was able to call get age. All right. Good refresher.
Is that what you were talking about, the difference between compile time and runtime? Like,
So
did that
kind
well?
of, not in this situation because student is pure virtual, which makes C++ behave at runtime like it is in Java. If it wasn't pure, it would be compile time. Let us not delve too deep into this because it doesn't matter for this course that much. Really, if you're going to use virtual functions, just make them pure, and things are going to behave in a very simplistic manner. All right, that's nice. All right, list. Oh. Okay, I think that, are they going to go through a lot of this? All right, that's fine. So we're going to ignore the rest of those slides because they're kind of dumb. And we're actually going to stop now and then go over your next lab because I think that'll help explain more of what's going on in Lab 7.